Chemistry is not difficult. Chemistry is magic.
Hello everyone, welcome to my channel. Our today's topic is what is component and what is degree of freedom. Before we discuss our today's topic, let's take quick recap to our previous lecture. What we discussed in our previous lectures, what is phase, what is equilibrium. There were two phases, homogeneous and heterogeneous. In homogeneous phase only we can see one phase. It can be a solid, liquid, or gaseous, right? For example, air, lemanoid, water. And what is heterogeneous? The physical state chain, and there were two or more phases over there. For example, water in a soil, right? So, what is definition of phase? Homogeneous and physically distinct and mechanically separated from other part of the system. It is called phase. ફેઝ લિક્વિડ હોઈ શકે, gaseous હોઈ શકે અને solid બી હોઈ શકે. So what is liquid phase? Liquid phase is the number of liquid phase depends on the number of liquid present in their miscibility. If two liquids are immiscible, they will two separate forms. For example, benzene and water. If two liquids are miscible, they will form one liquid phase. For example, alcohol and water. Now, what is solid phase? This is more important. Each solid form a separate phase. એટલે કે જેટલા solid present એટલા phase present, right? Then after gaseous phase. Gaseous phase throughout miscible in all proportion. It will form only one phase, right? So this is all we discuss. So now we move on for our today's topic is component. What is component? It is denoted by C. The number of component of the system is the number of constituent expressed in the form of formula, or also chemically independent constituent of the system. In short, uh, for example, there are three forms of water: ice in a solid, water in a liquid, and vapor in a gaseous. They are chemically independent, right? Solid alag, liquid alag, gaseous alag, chemically independent, but we can express these only one formula, water. So above reaction, the chemical composition of all three phases is only H2O, right? એટલે કે બધી જ સિસ્ટમની ફેઝને આપણે એક જ ફોર્મ્યુલા વડે દર્શાવીએ તો એને કમ્પોનન્ટ કહેવાય, રાઈટ? અહીંયા ત્રણ ફેઝ છે અલગ અલગ, બટ એને આપણે એક જ કમ્પોનન્ટ વડે દર્શાવી શકીએ, H2O, એક જ ફોર્મ્યુલા છે તો એને શું કહેવાય? કમ્પોનન્ટ્સ. And definition is the number of component of the system is the number of constituent expressed in the form of formula or chemically independent constituent of the system, right? So this is called component. But the number of component is 1 for water, right? Another example, sulfur exists in 4 phases, namely rhombic, monoclinic, liquid sulfur and vapor sulfur. But the chemical composition is only one, sulfur, right? There are 4 phases, but બધી સિસ્ટમને 4 phase છે, but આપણે એને એક જ ફોર્મ્યુલા વડે દર્શાવી શકીએ, sulfur. Hence it is only one phase, right? Another example, thermal decomposition of CaCO3. Now we can heat CaCO3 and we can get CaO plus CO2. This system has 3 phases. As I tell you above, each solid form a different phases. એટલે કે જેટલા solid present એટલા phase present. So here two solids, CaCO3 and CaO. So here two phases present and another one is gaseous. So total phases is 3. But what is the number of component કેટલા છે અહીંયા? So this system has two components, as the composition of each of the above phase can be expressed in the equation considering any two of the three phases present. એટલે કે CaCO3 converted CaO plus CO2. So CaCO3 and CaO we consider one component and CO2 we consider second. So here total components is 2, right? So another one reaction is PCl5 gives PCl3 and Cl2. So this system has also three phases and two components, namely PCl3 and Cl2. Now, so another reaction is PCl5 solid, it gives PCl3 liquid plus Cl2 gases, right? So this system has three phases and two components, namely PCl3 and Cl2, right? An aqueous solution of NaCl is a two-component system, water and NaCl. Aqueous solution આપણે શેમાં બનાવીએ? Waterમાં, right? So these constituents are NaCl and H2O. Now, in the dissociation of NH4Cl, the following equilibrium occurs. NH4Cl solid, it forms NH3 gas plus HCl gas. So how many phases here? The system consists two phases, namely solid ammonium chloride and the gaseous mixture containing ammonia and hydrochloric acid. So here, when NH3 and HCl is present in equivalent phase, it can be expressed by NH4Cl. So the system will be a one component system. So now you also can consider partial pressure are same. So NH4Cl and NH3 consider as a one component system, right? Moreover, so what is degree of freedom? You can also call it degree of freedom or variant, right? So what is definition? The minimum number of independent variable factor such as temperature, pressure, and concentration of the phases which must be fixed in order to define the condition of a system completely. It is denoted by F. So smallest number of independent variable એને શું કહેવાય? ડિગ્રી ઓફ ફ્રીડમ. હવે કોઈ બી રિએક્શન છે એને ઇક્વિલિબ્રિયમ કન્ડિશનમાં લાવવા માટે વેરિયેબલની જરૂર પડે. તો એ કયા વેરિયેબલ છે? તો કે ટેમ્પરેચર, પ્રેશર અને કોન્સન્ટ્રેશન, રાઈટ? તો મિનિમમ નંબર ઓફ વેરિયેબલ ઇન્ડિપેન્ડન્ટ, તો એને શું કહેવાય? ડિગ્રી ઓફ ફ્રીડમ. A system having 0, 1, 2 and 3 degree of freedom, so it is called non-variant. If system having 0 variable, right, so it is called non-variant. If system having 1 variable, so it is called univariant, or you can say monovariant. If system having 2 variant, so it is called bivariant or divariant. If system having 3 variables, so it is called tri-variant respectively, right? So here some example. Consider the water system. Water કેટલા ફોર્મમાં પ્રેઝન્ટ હોઈ શકે? તો કે આઈસ એટલે કે સોલિડ ફોર્મમાં, વોટર એટલે કે લિક્વિડ ફોર્મમાં, અને વેપર એટલે કે ગેસિયસ ફોર્મમાં. So the three phases can be in equilibrium only at particular temperature and pressure. હવે આ ત્રણેય ફેઝ છે એ કોઈ પર્ટિક્યુલર પ્રેશર અને ટેમ્પરેચર પર જ હોઈ શકે. તો ત્યારે જ આપણે એને કહી શકાય કે this equation is in equilibrium state. જો તમે ટેમ્પરેચર ચેન્જ કરો તો પ્રેશર બી ચેન્જ થાય, રાઈટ? પ્રેશર ચેન્જ કરો તો ટેમ્પરેચર ચેન્જ થાય. So here we can say that temperature and pressure fix. So this system is in equilibrium. So therefore, when all the three phases are present in equilibrium, then no condition needs to satisfy. આ સિસ્ટમ ઓલરેડી ઇક્વિલિબ્રિયમ કન્ડિશનમાં જ છે, તો આપણે ટેમ્પરેચર કે પ્રેશરને કંઈ ચેન્જ કરવું પડશે નહીં. So then no condition to needs to be satisfied. So this systems therefore zero variant or no degree of freedom. આપણે કોઈ બી variant change કર્યો નથી તો એને શું કહેવાય zero. That means zero variant, right? Further, in this system if pressure or temperature is alternate, right? આપણે pressure અથવા તો temperature બેયને આગળ પાછળ કરીએ, so their phase will not remain in equilibrium. So one of the phase is disappear. For example, ice in a solid form. If temperature will increase, then ice liquid માં converted થઈ જશે, બરાબર? So are you getting my point? So this is one univariant. એક variable ને change કરીએ તો univariant. Moreover, consider a system consisting of water in a contact with vapor. So liquid water in a contact with water vapor in a gaseous form. To define this system completely, we must state either the temperature or pressure. So the degree of freedom is 1. એટલે કે આ રિએક્શનને આપણે ઇક્વિલિબ્રિયમ કન્ડિશનમાં લાવવા માટે આપણે આઈધર ટેમ્પરેચર ચેન્જ કરવું પડે, આઈધર પ્રેશર ચેન્જ કરવું પડે, રાઈટ? સો આપણે બેમાંથી એક વેરિયેબલ ચેન્જ કરીએ છીએ તો એને શું કહેવાય? આપણે 1 degree of freedom. So this is called system consisting of water vapor phase only. So we must state the value of both the T and P in order to define the system completely in a bivariant, right? Furthermore, in gaseous mixture of N2 and H2, we must state both the pressure and temperature, because if temperature and pressure are fixed, the volume automatically become defined. Hence, it is a 2 degree of freedom, right? So this is for today. Thank you.